Hello, this is Captain Chaudhari. In my series of videos on basic stability calculations, in my last video, I did the principle of Catamarine, where the stability of the single hull was not appropriate, not up to the mark. In fact, it was negative. And when we joined the two hulls, it became a twin hull vessel. We found that there was considerable increase in the stability of the ship. The stability of the single hull was negative, we had seen, and when we joined the two hulls by weightless platform, just to make the calculation simpler, we found that the stability improved considerably. Right? So there we had joined the twin hulls which were box shaped. Now we are going to do the same calculation for twin hulls which are of ship shape. So let us say this is one hull, this is the identical hull, and they are joined by the weightless platform, right? Okay. Now, because of weightless platform, what happens? The kb does not change, kg does not change. In this question, we are required to find out what is the change of gm. So this particular question can be done this way. Gm transverse is actually kb plus bm minus kg. Now, before transformation, there was certain kb and certain kg, right? Because the weight on top is not changing, it's weightless platform, I would say after joining, the kb of the combination remains same. Similarly, because the platform was weightless on top, the kg also would not change. So if we consider the initial gm transverse and final gm transverse, after the twin hull, after the weightless platform was joined on top, the new GM transfer, let's call it GMT1, would be equal to KB plus BM minus KG. But what is the change of GM? Right? Change of GM would be 2 minus 1, but when we subtract 1 from 2, kb gets cancelled, kg gets cancelled, because there is no change in kb, there is no change in kg. So can I say bm transverse 2 minus bm transverse 1. So change of bm in this particular case, the change of bm would be change of gm. So let us find out what is the change of bm in this case, right? So bm, as we know, is actually moment of inertia upon underwater volume. So bm transverse for the single hull, bm transverse is equal to moment of inertia about the centerline axis passing through the center of flotation divided by underwater volume. Now if we look at the water plane area of a single hull, right? So bm transverse is moment of inertia about this axis divided by underwater volume. Now, what is moment of inertia about this axis is not clearly given in this question. So let us assume that the moment of inertia about this axis is actually I, right? That divided by underwater volume. What was the underwater volume? The displacement is 248 tons. And let's say she is floating in salt water, divided by 1.025. So 248 divided by 1.025. 248 divided by 1.025 gives me 241.95. 241.95 meter cube is the underwater volume. So can I say that the BM transverse initially was I divided by 241.95. Now here TPC is given as 0.5. TPC of individual hull is 0.5, and I always tell my student TPC is the tons per centimeter, how much you would load on the ship so that the mean draft changes by 1 centimeter. TPC has to be also understood as indirectly telling you what is the water plane area. If your ship's TPC is 50, that means approximately your ship's water plane area is 5,000. Multiply by 100. If you want accurate, you divide by 1.025. So water plane area of each hull is 0.5 into 100 divided by 1.025. That is 50 divided by 1.025. That gives me the water plane area as 48.78. 48.78. So what is the moment of inertia of the combination about the common center line? Moment of inertia we know about the own centroid and 4.5 axis is I. If I take this moment of inertia to the center line, it will become I plus AD square. Area is 48.78 and D should be 3.5 square because center line to center line distance is 7 meters. So center line to common center line would be 3.5 meters. But this moment of inertia that comes from one hull has to be multiplied by 2. That is the total moment of inertia about common center line. Now this divided by total underwater volume. Total underwater volume should be 2 multiplied by 241.95. That is the total underwater volume, and this should be equal to new BM transverse. Right? So new BM transverse, let us slightly simplify this. Right? 2 gets cancelled and we have 3.5 into 3.5 into 48.78 equals, that is 597.56. 597.56 plus I divided by 241.95. This is the BM transverse 2. And what is the BM transverse 1? BM transverse 1 is equal to I divided by 241.95. So the change in BM is equal to change in GM. Change in GM is equal to change in BM. So change of GM transverse is this expression minus this expression, right? The BM after modification minus original BM. So what happens in this particular case? There is a common denominator, that is 241.95, and if we combine the two numerators, the I gets cancelled and what remains is 597.56, right? So let us see how much it is. 597.56 597.56 divided by 241.95, 2.46 and 2.470. This is 2.470. So there is an improvement of GM by 2.470 meters because in this particular case KB and KG was not changing, so it became simpler for us that change of BM is equal to change of GM, or change of GM is found by finding out what is change of BM, and here it is 2.47 meters is the improvement of the GM.